Hello everyone. In this video, I will first talk about the background of kernel density visualization, KDV, and then I will illustrate how our system, KDV-Explorer, can support KDV to generate a heat map in near real time, which is more than 5 seconds, using only a single CPU, which cannot be achieved by other GIS software and research studies. As a remark, this demo system is based on our recent work called CORD, which was published in Sigma 2020. KDV is a commonly used visualization tool for spatial analysis in a wide range of applications, including traffic accident hotspot detection, crime hotspot detection, disease outbreak detections, etc. Therefore, the most popular geographical software, for example QGIS, ArcGIS, can also support this operation. As you can see here, QGIS offers this heat map operation, which is based on KDV to generate the visualization. Although QGIS and ArcGIS can support KDV, it is very time-consuming for these types of software to compute KDV. Using the crime dataset here as example, this dataset contains 270,000 data points. If we generate KDV for this dataset using this QGIS software, it takes us nearly 5 minutes for a single visualization, let alone to efficiently support KDV, which is more than 5 seconds for the datasets with medium scale data points. On the other hand, due to the inefficiency issues for using KDV, some research studies propose to utilize GPU or parallel or distributed computation to improve the efficiency for computing KDV. However, this approach needs to consume many computational resources, for example, 16 computers in parallel with 1 GPU for each computer. Here, we ask a question: can we efficiently generate KDV, for example, more than 5 seconds, without using many computational resources? We provide an affirmative answer to this question in this demo. Here, I will show you that our system KDV-Explorer can support near real-time heat map generation for datasets with medium-scale data points under the single CPU setting, which means, first, no GPU, second, no parallel or distributed computation. Here, we use the traffic accident dataset in New York for demonstration. This dataset stores the latitude and longitude coordinates for the traffic accident events. The total number of these events is nearly 1.3 million, which is 4.8 times larger than the crime dataset that I've shown you before. Now, let's generate KDV in New York. Even though this dataset contains 1.3 million data points, we can find that KDV-Explorer can generate a heat map within 5 seconds. You can see that Manhattan seems to have the high density for traffic accidents events in New York. As a practical user, for example, transportation experts, you can have more questions. For example, which region in Manhattan is a hotspot of traffic accidents? Therefore, KDV-Explorer offers the exploratory operations. That means zoom in and zoom out for the users to visualize more interesting regions in province level, city level, or street level. Now, let us zoom into Manhattan. Change the bandwidth to 15, and then click Run again. Then we can instantly obtain another heat map which shows more detail compared with the previous one. Besides the zoom-in operation, the users can be interested in visualizing hotspots in other regions. Therefore, KDV-Explorer offers another exploratory operations, that's mean planning. Let's now plan the screens to the south part of New York. And then click Run again. You can see that this part is also the hotspots of traffic accidents. Compared with our preliminary work in Sigma 2020, KDV-Explorer supports more commonly used kernel functions, including chaotic kernel and Pennycoff kernel. In practice, domain experts adopt different types of kernel functions for heat map generation. For details, please read section 3.4 in our paper. Now, let's show you the results in 2 famous kernel functions, which are Gaussian and Pennycoff kernels. First, let's show the results of Gaussian kernel here. Then we show you the results of Pennycoff kernel here. We also offered other datasets, for example, COVID-19 datasets and crime dataset in Atlanta for the audience to visualize the hotspots in other applications. As the concept is similar, I will not show the demonstration for these datasets in this video. Please visit the project websites for more details.